see it?
Yes, we see it.
I think so. Okay. Well, thanks a lot. So, and good afternoon, everyone. So, I'm here to talk about recent work and ongoing work to try to improve high latitude representation in the global CAMS system. And this work, sorry, got, this work is done in the context of CAMS, of course, and of camera. And let me.
You're not sharing the screen, right?
Okay, here. And so CAMS basically basically the slide that Mark Barrington showed this morning. It's composed of a global system IFS compo and a regional system that I'm not showing here using Earth observations from satellites and ground also to provide a lot of products that are used well by many of you around the table, I guess. So what we do here is an IFS composed of a global system that's simulating aerosols and chemistry in troposphere and stratosphere. And this work is done in the context of a Camera Horizon Europe project, which is basically in support of the CAMS, so global CAMS and regional CAMS. Our aim shortly is basically to improve the aerosol modeling capacities of a global CAMS system. And so that basically what we do should be implemented operationally in a few years' time in the global system. So what I'm showing here is really ongoing development, nothing that is yet operational, but which should come in the coming years. So stay tuned for that. And we have a lot of planned dust-related work. We plan to try to provide some global dust emission best estimate IFS compo online to use this to train a machine learning model to estimate global dust emissions, to estimate infrared radiances. That's linked with another Horizon Europe project called Cameo, and also to work on road dust emissions, focusing on Europe in the EMAP, EuroDM, Lotus Euros models, and to focus, then that's the last item, on high latitude dust for IFS compo. So that's what I'm going to talk about today. And this is, of course, work that's very fresh. The project started only 1 year ago, and we're still, let's say, working on stuff. So the modeling of dust emissions in IFS compo is quite a simple scheme. Something that's used widely, the Marti-Corner-Bergametti sandblasting scheme, and we use it with a Koch et al. Dust at emissions. So of course, the critical inputs are friction velocity, soil wetness, and the fraction of soil that's composed of silt, sand, clay. We also tune that by a dust source function that's computed by comparing simulated and retrieved dust AOD. We have 3 dust bins in the operational version, and we're working now on an experimental version with 6 dust bins, which is much better to represent sedimentation, transport, etc. And of course, there are a lot of challenges, which all of you know about dust emission simulation modeling, uncertainty of some inputs, soil topology, erodible surfaces, etc. The difficulty to try to represent small-scale processes with 40-kilometer grid cell, and for high-latitude dust, some specific issues, which I will come back later. We try to update our dust modeling frequently, and this is just a summary of the past updates of the global system that related to dust, with a new dust function in 2020, some new deposition schemes in cycle 47 and 3, new optical properties recently, and now we try to represent dust asphericity and hydrophilic growth in cycle 49R1, which became operational last November. And cycle 50R1, we are thinking about adding bins, but maybe it will be for later cycle. It's still under discussion. So now to come back to specific problems about high latitude dust sources in IFS compo. The main problem is that we use actually a modulation of dust source dust emissions by a monthly dust source function that's been computed by comparing simulated and retrieved dust AOD. And then usually these dust AOD products, I mean, we rely on MIDAS, they show quite little signal over high latitude dust source regions, which means that basically we just say that there's really little sources over most of the high latitude regions, north or south hemisphere. And second, of course, we use a 40-kilometer grid cell. So the horizontal resolution is really quite coarse. And most of the high latitude dust source seems to be quite local, at least more so than the Sahara or like Saudi Arabia, etc. I mean, here are shown basically the operational dust source function in May, and you can see that there's hardly any signal of like high latitude areas. and the land sea mask, focusing over Iceland, Greenland, and part of UK, where you can see that really the features of Iceland are very roughly represented in terms of land sea mask. So that's one additional difficulty, of course. So what we try to do currently to overcome those difficulties is one first option is to update the dust source function manually, more or less, to take into account, to force it to take into account high latitude dust sources. So for this, we use data from this gross vasting paper, which they use FlexPart, I think, in it, and we merge it with the operational dust source function. And over Iceland, you can see the result. We are testing two variants, where you can see that we do have some potential for the sources over the south coast and a little bit over the center of Iceland. A second option is to actually overhaul the whole dust emission scheme, and it's what we're trying by implementing a new dust emission scheme that's been adapted from the SILAM dust emission scheme. And this scheme is actually using an input derived from surface roughness itself from remote sensing. We are testing three options. I'm showing only one in this talk. This is actually the input in question, which is basically as a function of surface roughness. And you can see that over Iceland, there is the potential to have the sources actually. So that's at least possible, which is a good thing. So now turning to first results with these different approaches. So first on the simulated dust surface concentration. So we are carrying out simulations with IFS Compo, so it's global, but we focused over Iceland here. And we simulate the whole of 2019. Here I'm showing only June 2019 because that's where we have data. I mean, the simulations are still ongoing. And we use the IFS Compo without any data simulation because our aim is really to validate how the model is behaving without the use of observations, let's say. And here in this slide, we are showing the impact of using different, so the updated dust source function, so forcing the dust source function to have high latitude dust sources. And you can see that it works more or less as intended in the sense that we have no dust source concentration in June 19 on the left-hand side. And we see a signal of a central South Iceland. More so, of course, if we have like a dust source function that's allowing more dust emissions there. And also a small signal of a southeast Iceland, let's say. So that's just exactly that something is happening. We don't know yet if it's a good or bad thing. And if we zoom out a little bit to the whole of the North Hemisphere high latitude dust, we can see that we also have a signal over like Ellesmere Island, so some parts of high latitude Canada and Siberia, where we do see some additional dust, total dust source surface concentration, as compared to the reference run, which has very little in those regions. So now moving to the other option, which is to basically change the dust emission scheme. We compare here, so for June 2019, the simulated dust surface concentration. On the left-hand side, the reference with nearly nothing, and the right-hand side with the new dust emission scheme, where we have values that reach up to 50 or 60 microgram per cubic meter over most of central Iceland. So it's a different signal as compared to updating the DSF, where you can see that the range, the area that's impacted by desert dust is quite different. Again, we don't know yet if it's a good thing or bad thing, but at least something is happening. And when we zoom out over the whole of the Northern Hemisphere, we can see that Iceland is, of course, impacted, but also, some part of high latitude Canada. Of course, there's a much larger signal over like the main dust emitting regions of Sahara, Middle East, etc. And when we turn to PM10, that's again comparing simulated PM10 with the different options. We can see that with the operational dust source function, so we have a signal of PM10 from sea salt aerosol sources, but then very little values, very small values over most of Iceland, which are then higher the southern coast with the high latitude dust tuned dust source function. And with the new dust scheme, we do have a PM10 signal over most of central Iceland in June 2019. We try not to compare what we do to observations, which is hard because there's really not that many of them available in high latitude regions. We first look at Aeronet, and there's a station in Reykjavik and also in Kangerlussuaq, which is in southwest Greenland. We can see that basically in this plot, they show like observed and simulated AOD at 500 nanometer. And dust AOD is shown, the simulated dust AOD is shown in dotted lines. And basically, these simulated values are really quite small for dust AOD. So the signal in terms of AOD seems to be not very large, at least in these simulations. But of course, when we move to PM10, the signal is much larger. So we compare against PM10 observations over Iceland. I'm showing here the network on the top right corner. You can see that the network over Iceland is very uneven. So it's really focused over Reykjavik area and a little bit over the north coast. So what we show here as an average over 6 sites is really, well, heavily biased over Reykjavik. But well, I mean, we do with what we have, of course. You can see that as compared to observations, which are in blue, our green reference is really low biased. I mean, we miss a lot of PM10 from different reasons, of course. And we can see that the new dust emission scheme fares really a little bit better. I mean, we're still way too low, the red line, but some events, some spikes of PM10 are clearly better represented with the new dust emission scheme. The source function tuned to get high latitude dust sources is increasing, of course, PM10, but it seems to be less aligned with the simulated, with the observed peaks of PM10, at least over Iceland. And if we look now at just a scatter plot of simulated versus observed PM10 over the whole of Iceland, we can see that the operational so without data estimation is really not that great. I mean, we have a very strong low bias with a mean value of 3.3 microgram per cubic meter versus 7, and a correlation of 0.39, which is really not great. This is slightly improved by the high latitude dust source function with a operational scheme. We can see that the low bias is improved, moving to like 4.2 or 5.2 microgram per cubic meter. And that correlation is also improved, 0.48, which is not great, but still better than 0.39, and 0.44 with the highest version. So it's helping a bit. It's not like a crazy improvement, but at least it's going in the right direction. But now, if we consider results with a new dust scheme, of course, this is only for 2 months. So we need to check out like a longer simulation to have more robust evaluation. But we can see that the correlation is very much improved again, moving up to 0.58. So that's a very nice improvement as compared to the operational, and that our low bias is decreased. I mean, we still have one, but it's less intense. So that's basically what I wanted to show you. I mean, those results are really hot from the oven. I mean, those simulations are still ongoing, and that's why we have only 2 months of data. But they're quite promising, and we see that clearly the new dust emission scheme seems to work better over Iceland at least, and it works better than just updating the dust source function of the current operational scheme. We need, of course, to do this kind of evaluation for a longer period of time to have some more meaningful results. I mean, those are really a first preview of what we are doing. But yeah, of course, this evaluation is not easy because we have very sparse observations, and remote sensing is not always great over those latitudes, and the signal for AOD is not very large, of course. What will come next is to try to use actually the PM observations, in particular from Iceland, or extra observations to evaluate the model. That would be great. So to try to fill the gap that we have over Central Iceland, that's something that we'll try to do with the help of Pavla and colleagues. We would try also to maybe integrate this dust source erosion map that has been provided by Pavla kindly, so that I'm showing here on the right-hand side. And something I would like to do, of course, at some point would be to maybe compare our result to Dream Iceland, because that's really quite a reference for Icelandic dust. And that's something that would clearly help us to better understand what we do right or what we do wrong. Okay, so that's it for me. Thank you all, and I'm happy to take any question.
Thank you, Samuel. Do we have any questions? Yes. So okay, you have that.
Thank you, Samuel. Nice and good progress. I have a question a bit from other side. I already mentioned it in my presentation about a Vigny study of aerosol impact on meteorology, where you was one of the participants. At that time, when indirect effects were included for case study over Egypt, signal was in different directions between these 5 models were what used. Now it was second phase of this aerosol study in Vigny. Is there some progress and better improvements of indirect effects in the current models?
It's not something we work too much on. I mean, I know it's seamless. So in CAMS, it's really outside of scope. I mean, that's like NWP aspect. It's a bit of a pity because I would like to work on it at some point, but it's not something we really work in CAMS. It's not the product that are provided by this service. I know SMDF colleagues are working on trying to couple like CCN with aerosols, focusing not really on desert dust, but other, well, all species. So there's some experimental progress, but not really in this scope of CAMS.
Okay, well, thank you.
Okay.
Thank you so much for your interesting presentation. I
Pleasure.
just had a couple of questions. The beginning of a presentation, I saw you claim that the high latitude sources are little based on the MIDAS data, MIDAS aerosol optical depths, which I think is true and convincing from our optical views over that area. Just needed to know if you had any criteria or condition for that investigation on MIDAS data. How did you just concluded that? And the second thing is that do you have any bigger scale of that figure to see more closely the Canadian Arctic region and to see more closely the results for that region?
Yeah, so the first question is about MIDAS and high latitude dust. Did I understand correctly?
Yeah.
Yeah. Well, I mean, MIDAS is basically based on MODIS, and we derive dust. So, I mean, and some modeling from geoscheme, I think. And I seldom see any high latitude dust signal from MODIS, at least. We see biomass burning clearly, but every time I look, of course, it's not like a quantitative study, but clearly I have the impression that AOD from high latitude dust events is hard to come by, let's say, in terms of large amount or large numerous occurrence in MODIS and in MIDAS. So it's not, I mean, I don't have numbers to back this, but clearly when we use this product to tune our dust source function, the result is that we have nothing in high latitude, which is really not great.
Okay. Thank
And
you.
the second question, I'm not sure which figure you want. That's about the. Maybe I can.
Just that figure that that MIDAS figure that you just showed.
Oh, it's not MIDAS. I mean, what I showed was the dust source function. So that's you. Let's say we used MIDAS to come to that, but it's not MIDAS itself.
Oh, okay. Thank you so much.
Pleasure.
I think we have some questions on the chat, right?
Yeah. Have you tried comparing your model with Ca plus or aluminum, I guess, Al, when using PM10? We do this kind of evaluation of Ca plus, but mostly for sea salt, actually. Well, no, Cl, actually, that's NaCl. Now, for Ca, we do that, but over Europe, are there some stations over Iceland for this? Because we look at Ca plus, indeed, over Europe and US. That's yeah.
All right. Thank you, Samuel. And I think we're right on time for the next
Pleasure.
presentation. So I'd like to welcome now our next speaker, Christina Ananasso from ECMWF, and she'll be talking about the overview of Copernicus hubs for health and so Christina, if you're ready, the floor is yours.
Yes, I'm ready. Can you hear me?
Yes, we can hear you.
Okay, good. So let me share my presentation. Give me 1 second.
I think Samuel, you're still.
Can you,
Yeah.
do you see my slide in a present? No, wait. In a presentation mode?
Yes, now we see it in the presentation mode.
Okay, perfect. So thank you for having invited me to this workshop. I hope not to disappoint you because I'm not going to give a scientific presentation indeed. So I'm going quite far, I imagine, from the previous presentation that you have today. But I'm pleased to present a kind of a programmatic approach that we have at ECMWF for two important topic, health and energy, where indeed the dust can play an important role. So my name is Cristina Nanasso. I work at ECMWF since 3.5 years now, and I am the team leader of the Copernicus National Uptake and Thematic Collaboration, and I mainly collaborate with colleagues from Iceland for the CAMS National Collaboration Program. As I said, I'm going to present the Copernicus Health and Energy Hub that I still consider a kind as a new approach toward the user, even if new now as almost 3 years, because we started with these activities in the ongoing, in the current multi-annual financial agreement with the agreement that we have now with the Commission for the developing of the two services, CAMS and C3S, and also of these two AMPs. You see on the right the Rubik's Cube, that is, in my opinion, a nice way to present the hub, because in Copernicus we have the services. The services are operational since a while. There are 6 core services. Atmosphere, climate change are the 2 that we are in charge of as ECMWF. Then we have land, marine, emergency and security. They are there since a while. As I said, they produce and provide in an operational way products and added value data. And then we have the other 2 sides of the cube, where we have the closer collaboration with the countries, and this is what we call the National Collaboration Program. And indeed, this is also valid for CAMS and for C3S. And then we have the collaboration based on a specific topic, based on specific needs coming from 2 different communities. For ECMWF, we have the health and the energy community as a reference. Then there are other 2 AMPs developed by Mercator in the context of the marine service, that are the Arctic Hub and the Coastal Hub. So the, let's say, 4 pillars of these hubs are reported in this slide. The idea is really to collect all the information, all the data set, all the use cases coming from the different Copernicus component or related project. And the idea is to coordinate them and to give the first entry point on a website for these 2 communities. We would like to create also our own community, bringing scientific knowledge, technical expertise, and responding somehow to some specific user need. What we want to do is to understand better the needs of our user. We are not expert on health and on energy. We as ECMWF, we are expert in atmospheric composition, modeling, Earth observation data, simulation, climate, and so on, but indeed not on health. We bring together also example on how data can be integrated with our data. So to provide other, to foster ideas for further research and application. So in the website, you can find user stories or use cases where Copernicus data are indeed used, but not only. And then we would like also to leverage collaboration and interaction that already exist among the Copernicus entities, but also with external stakeholders. So as I said at the very beginning, this is really a kind of programmatic presentation. When we started A couple of years ago, at least in 2021, there were some discussion between the entrusted entities and the Commission on how to develop these hubs and which are the topics that we should consider in these hubs. Then in 2022, we started to address the points that I mentioned before. And formally, the launch of the hubs happened during the EU Space Week in November 2023. The 4 hubs were presented to the space community, or let's say to the space community as part of the European Union. Now we had let's say a standby period for our activities, but now we want to ramp up with a new website with a, let's say, more attractive way to guide new user through our data set. And it's important to understand that in this case, our is not only ECMWF, but it's really Copernicus. So what is for us the Copernicus Health Hub? The idea, in particular for the website, is to have a centralized platform that provides Earth observation data, products, information to support activities in this domain. The idea is not only to offer this data set, because the data sets are already there, but the idea is to facilitate the access to this data set and to this user story for people that is not expert on Earth observation, but people that in theory should come from the health community. To do so, we have categorized our products and our use cases based on the categorization that was developed by WHO, the World Health Organization. So physical health, mental health, and well-being. The same for the Energy Hub. In this case, obviously, also in this case, our users from this domain come from policymakers at the European or national level, public administration, industry, NGOs. And that's the information that we provide should support the green energy transition, the energy security, and the climate resilience. The key focus areas are the one reported here. So from one side, indeed, how Copernicus can support the renewable energy sources, and also some other more infrastructural element of the energy world. There are a lot of things in this slide, but just to tell you that here are the 2 hubs. We are ECMWF, and we are developing this under, let's say, the control of the European Commission, obviously in particular DEFIS and the JRC that are also in charge of the Knowledge Center for Earth observation. And this center is addressing the policy needs of the different DGs, of the different directorates general at the European Union. As I said, we ask for, and we are looking for, still contribution from all the services as part of the Copernicus program. As I said, we are not expert in the 2 domains, but we are following the guidance, let's say, or the advice of advisory boards. There are 2 advisory boards, one for health and one for energy, and the people that are part of this advisory board are indeed the expert on the 2 topics. On the right-hand side of these slides, you will find our, let's say, stakeholders or potential users, so all the domain of the institution at European level, even at global level, like, for example, IRENA, the International Energy Agency for the Energy, and all the things that is closer to the health, all the institutions that are closer to the health domain. And then here a more generic definition of our stakeholder. Indeed, so we have the member state, not only through the national collaboration programs, but also based on somehow bilateral activities. academia. We want to address also press and media that can maybe need some specific information that could be found on the website, general citizens, and also the NGO. What is currently available? There are several use cases and several user stories that had the goal to inspire users that are entering in our website. There are already 27 for health and 10 datasets for the energy, but we are going to improve these figures. And then you have information on projects somehow linked to the health sector, and for the Energy Hub, some link to already available training resources for people that are interested to use the specific products. This is an example of the data set that we collected for the Health Hub. As I said, all the entrusted entities, all the services are involved, and they gave us the list of the products that they consider relevant for the Health Hub. And you see here the list. I'm not going to read, only a remark on the fact that for the what we call the environmental services, the data access is free, full, and open. The policy for the data access is still is full and open. For the security and emergency services, there is a regulated access. So don't expect to have access to all these products easily, because indeed these services are developed for, let's say, national recognized formal user. These are the data set collected from the different services for the Energy Hub, and you can find some nice picture on the right-hand side of the slide. Few examples. I reported the only couple for each service, but indeed, if you go on the website, it could be nice for you to read some of the already existing use cases. The first one is from C3S, where the idea is to investigate more how the intensification of the climate extreme, in particular the health, the climate change in the Mediterranean area has an impact on health. And on the other side, you have a product and a use case using data from products coming from CAMS, EV radiation and ozone layer that indeed are quite harmful for our health. These are two examples for the energy one. Muatwat Solar, it was a project, a use cases developed a few years ago, where I wanted to underline and somehow remark that the successful of some of these use cases, the fact that they are using CAMS data, in this case, the solar radiation data, together with different kind of information. And in particular, in this case, there are information linked to city planner, for example. In this other example, again, for a kind of application at city level, we have this built space that's using C3S data with other kind of data that are, from example, coming from in situ observation or from another service that is the land service. And this is to determine the ideal location to install a solar energy panel, for example. As I said, we had a kind of standby period for the two apps. Now we have a few contracts in place that should support us in improving what are the hub now, the website in particular, and also to support us in creating this community around the app. So this is for us a very important goal. So there will be more articles, the definition of use cases, including also more data set coming from the different service that can contribute. And we would like also to start organizing a short webinar events where we can collect also requirements and needs from the different communities. Which are the added value of these apps toward the community? Indeed, there you can find reliable and sense-based information for different users, policymakers, researchers, industry, and professionals. And we really would like to address all these different communities. Somehow, our data, in general, the Copernicus data, should improve the decision-taking process using high-quality Earth observation data. We would like really to increase the number of use cases and best practice, because in this way you can really demonstrate how our Copernicus data can be used and really to inspire new user. And then we would like also to improve the collaboration among the trusted entity. This is more a kind of internal goal at Copernicus, but also the collaboration with other stakeholder or in general, what we can consider as a user community. We are collecting this user testimonial. So if you are interested, please take a screenshot of this QR code and propose your testimonial. If you are working or if you had a past project on health or on energy, we want to create a database for these user testimonials. And the idea is that after a kind of, let's say, selection, we would like to make from this database some nice use cases to be presented in our website, but in general also in this kind of presentation. So it can be a kind of shop window also for your project. With this, I close my presentation. I hope that you really a bit appreciate, even if it's not really scientific, but maybe you can find a nice way to collaborate with us. Thank you again.
Thank you, Christina. A very nice presentation. Do we have any questions from the audience here? No, anything in the chat? I see there are a few questions. I think. Yes, I think if you have any questions, you can just reach out to Christina, and I think she'd be more than happy to answer those. And I think
Thank you.
Thank you very much, and we're right on time for our next speaker, Hilnir Arnason. I hope I pronounced that right. He's on site. We'll be talking about new air quality Iceland page. So, Hilnir.
The folder with the presentations. Without talking to this.
Yes.
Yes, bro. Yeah, bro.
So, hi, my name is Hlynur Árnason. I'm an air quality specialist at the Environment and Energy Agency of Iceland. And I'm going to be talking about a new and improved airquality.is page, or loftgæði.is. This page is going to be a collaborative effort of the Environment and Energy Agency of Iceland, the Agricultural University of Iceland, the Natural Science Institute of Iceland, and the Copernicus Atmosphere Monitoring Service over in Europe. So, what is the current status of air quality data presentation in Iceland? Currently, we have two pages. There's loftgæði.is, which was developed and maintained by the EEAI. And then we have Loftgæði, which was developed in the first phase of the CAMS National Collaboration Program by the AUI and NSII. It was fantastic work by Paula and Michaela from the NSII. These sites have different focuses. So the loftgæði.is page focuses on displaying data about air quality in urban and industrial areas, while Loftgæði focuses on displaying data about dust storms in the highlands. And it has the added benefit of including CAMS forecasts. To show you just quick screenshots of both sites, this is loftgæði.is. Here we have a map of Iceland, and in these little bubbles, we have where they represent air quality monitoring stations around the country. Air quality is displayed in simple color codes, and if you click individual stations, you can get data about the air quality pollutants that are being measured there. And they are also represented as simple line graphs going back 24 hours in time. You can also select the individual stations and select a longer time period going back in time. And you can get this similar data, the simple line graphs and the tables. And you can also fetch this data as a CSV file. Other things we have is instructions for responses to air pollution from eruptions. We have SO2 forecasts during volcanic eruptions from both the Icelandic Meteorological Office and a private company called Belgingur. We also have instructions on what to do about volcanic smog, and then we have API support. Now, Loftgæði has a similar map of Iceland. Sorry?
I know this one.
Great, that's good. All right. Yeah, so as I said before, it has forecasts from CAMS. So for dust, PM10, PM2.5, and SO2, which is also nicely color-coded. It has other interesting stuff like land and soil data, and it marks the major dust hotspots around the country, which is the blue text and arrows around the country. And of course, it also has real-time monitoring for air quality and pollutants, meteorological data, and other stuff like road conditions, and a map of webcams around the country. And other features. I encourage you to check it out, of course. So what are we going to be doing with the new and improved loftgæði.is page? Basically, what we're going to be doing is we're going to be combining elements of both sites together. This should give us coverage of air quality in most of the country, or covering the whole area. We're going to have more forecasts from CAMS, so not only dust, PM, and SO2. We're also going to be having NOx and pollens, and possibly some more like ozone. Basically, what we want to be doing with this new loftgæði.is page is we want to put air quality information in layman's terms with an optimized user interface that's intuitive and interactive. And we want to have good accessibility for the visually impaired too, which has been lacking up until now. Importantly, also, we want to have mobile or a mobile version of the page, which currently neither of these pages has mobile support. And they look pretty janky on the phone, which is, of course, not great if you're out and about and you want to view air quality there. There's going to be other stuff like back-end optimizations, which are details that I'm not going to be going into right now. Now, this site is going to be developed in the second phase of the CAMS National Collaboration Program, which is set to end in April of 2028. And by then, we hope to have an easily accessible and intuitive site for day-to-day public use. So that's it for me. Thank you for your time.
What was the link to the
when you
Yeah, so that's lockdown.is.
It's too complicated.
Yeah.
I can actually share it in the chat.
Yeah, great. Thank you.
Thanks.
So questions, shall we open the question?
Is there questions in the chat?
Are there any questions here in the room?
Just answer.
Not specifically for about the website, but about monitoring of sulfur and other species, especially for volcanic ash monitoring system. It is very important to have some information about events and observation close to the source. And I remember what from this volcanic eruption, what we call E15. I cannot pronounce, sorry. That time, estimation of source term was done based on observation data from Iceland and around. Is there access to this data for example, WMO and international networks for volcanic ash and atmospheric monitoring?
Well, we have access to all the, at least in Lofke.is, all the data that has been measured way back. Yeah, and
So you're not responsible for the monitoring system, just use data for the website, right?
Yeah.
Okay. Well, it's not probably right address to the question. Sorry.
Okay.
There's a question from Santiago Gasso.
Mm-hmm.
Is there a social media presence for this initiative?
Well, when the website comes out, we're gonna post that on social media, on all our channels, definitely. Yeah.
That's not in Iceland.
Yeah.
Santiago knows the website.
One more question we have.
Yeah, a question here.
Yeah, so thanks for the introduction to the two pages. It looks very good. In terms of the data usage for research purposes, will you also provide later on a quality assured data series based on those different analyzers you have? I was just clicking around the webpage, you can see that it varies quite a bit, which kind of information you have for each monitoring node.
Yeah.
And I guess also the instrumentation will probably vary from maybe some low-cost sensors to more standardized reference sensors.
Yeah.
So will there be a quality assured database or archive where researchers can get access to the information?
Yeah, absolutely. We have that. Obviously, we can't validate the data in real time, but that's part of what we do at the EAI. We validate all the data.
Okay.
And yeah, you can get that from us anytime.
That sounds great.
Yeah.
Thanks.
And is the data available in hourly basis or daily basis, or can you use this aggregate it on the requirement? Do you know?
Yeah, it just depends. You can have an hourly or daily.
More questions? I guess we have from Alexander. Does the web page provide access to the historical data as well?
Yeah, we're gonna have that feature where you can have a time range where you can fetch the data.
Right. Okay, and another question from Santiago. What about webcams? Is there some webcams available with data?
Yeah, we're gonna include that since that's part of the Lofty yeah.
So are you maybe open for some kind of, let's say, project or whatever? If we are, let's say, interested to participate in something like this, since we have a model for Iceland. So if you are going maybe in the future to have an ensemble of models, except the CAMS model for Iceland.
Well, right now we're going to be using the CAMS model, and we're going to, as part of this project, but as another work package, we're going to help validate their forecasts. But yeah, I guess shoot us an email and we'll see.
Yes, of course. It's a plan. One question? Yeah, I would actually add myself also that the road system, the road administration system in Iceland, which is actually included in the map, has actually special warning sign for dust storms. So the drivers know that if there is this sign that you shouldn't really drive there, and you can also see how many cars have passed. So that's a kind of really good application for the daily use, to have this already implemented in the road also system in the map.
Is it a new feature?
It on the website of the road administration map, it's already has been there for some years. You can also see it by the road sometimes, sand fog in Icelandic, but they have a special, you can see now in the map, there is a part of Iceland which is having really strong winds, so we have the wind sign, and sometimes if there is a dust storm, you have the special sign, which is actually used also in the SDS, was the same one for the road closures. And then you see if the road is open or closed.
Now I'm on the website, but I don't see how to access to the webcam cameras.
You just
I see the webcam icon here, but
here,
you see here.
you just go to the layers.
Uh-huh.
No, sorry, so this one.
Yeah, I think
Maybe can you open it?
maybe just having a look on webcam cameras would be very interesting to us.
Sorry, I don't know if it's, and also, and los caídas, yeah, all right. Sorry, I write so slowly, but we have enough of time. Well, I hope we have. And then you go for the, move this one, English version, data. And here, real-time monitoring, and you select the webcams. Oh, sorry, meteorological data. Here are the webcams, and then you choose where do you want to go, like Vatnajökull?
Yeah, somewhere.
And then you see the pictures at the moment, how it looks like. Yeah, it looks actually like a dust. Yeah, and it was predicted by the model. Actually, this is usually very dusty place here. Yeah, you can see the visibility here is reduced.
So visibility is also index provided.
No, you would have to be
Because I
actually
think
discussed
for
it.
dust storm, it's easiest information which
Yeah,
can be
yeah,
used,
we discussed it because you
let's,
can have automatic visibility monitors, or you would have to have the
web
meteorologist.
service probably provides.
But yeah, this is automatic station. So, but it's actually a really good idea to anyhow get
But
information.
nowadays, there are also automatic station for visibility.
Yeah, and they are not so expensive, right? I
Yeah,
think.
it's not.
Yeah, that's something we shall actually
Most of countries,
suggest.
even developing countries
Days
now.
ago.
This new.
And then, yeah, and here are the stations for the air quality. So you activate them and then you see. And this is just, you know, the start. So of course the maps will be edited. And hopefully more models here. And I mean, any idea is welcome because the technical background, our
really
partner
interesting.
is incredibly talented. So really, they can do anything you wish.
I think it would be also useful to establish maybe some contact not only with WMO SDS VAS, but also with this volcanic ash observation system and prediction.
In UK?
Because, no, they have this ICAO centers for different, but for this region, it's UK.
Mm-hmm. And then we could also discuss it with Olav Ringpalsson and his, or is it already planned to have his model also, Belgingur?
No.
Yeah, so well, we are really open, depends on the technical background, what they can do.
Yeah, because for this, ICAO centers, it's important to get information for source assessment to start forecasting.
Mm-hmm. I actually wanted to add, there is also a user feedback, so you can send us email about your ideas. I am not sure exactly where is it, but that's important, really extremely important part for us to know what can we improve and.
I'm not sure.
And also, well, it's a brandly new open, so we still work on a screenshot measure. If it's not there yet, it's gonna be there very soon.
How's gonna be the maintenance of these webcam cameras? If because of the weather situation, they might be blocked with something. So
yeah, they're maintained by
do you have any
right?
maintenance group for
for the cameras?
Yeah, because I see a lot of cameras over the country.
Yeah. And I am not exactly sure about that. Who has it? It's also road administration. These are from road administration service, but there is basically a global website of cameras. You can see Antarctica, for example, or all those, but I don't remember exactly where
Maybe there is a procedure to clean them up every, I don't know, every days or every couple of weeks, days, I don't know. But I'm wondering this, if they got blocked with anything, then you don't see anything just because it is blocked.
You mean the visibility now?
Yeah.
Yeah, that happens very often, especially in the South Iceland. Okay. Now I know the webcams all over the world. You can see it on windy.com actually. You just activate the webcams. Yeah.
Is that good?
Yeah, so thank you. So thank you, Agnes, for convening the session. We will now stop sharing, and it was a great job because we are right on time, almost actually 2 minutes in advance. And let me see, we will meet us again after the coffee break for the remote sensing session and research strategy at 2:20 Icelandic time. Thank you.
Did you say 4:20, Heba?
Yes, 2:20 Icelandic time.
20 minutes later.
Okay, 20
Basically,
minutes
after
later.
20 minutes, yes.
Thank you.
Welcome.